Okay, so today I'm going to show you how to use MATLAB on our HPC systems in a different way from the way I did last time. If you jump back in time to January, a much younger me with a lot more hair showed you how to export a MATLAB graphical user interface session through X-Windows and have that running on a compute node, but then have the graphics for that running on your desktop. And that's not although that works, that's not a great way of doing it for all sorts of performance reasons. So I'm afraid before I get to how you should do it, I'm going to give you a bit of a history lesson. So what is X-Windows? So X-Windows was released in 1984. It adds a graphical user interface onto Unix. It allows multiple graphical terminals or workstations to run applications on other Unix machines or machines that run VMS, and for the GUI to be piped back to the desktop. And one of the reasons it's interesting is they made some quite odd architectural choices. So in sort of modern terminology, you would think of the workstation or the X terminal being a client and it connected to a server. But in X Windows, this is backwards. The server runs on your desktop, and the clients are the applications which connect to it and send that server graphical commands to do and get input back from it. This is quite a nice model because it means you have one desktop, which is the server, but the clients can be anywhere on the network. So they could be on your workstation, they could be on a departmental Unix machine down the hall, they could be on an HPC system you have access to on campus. But regardless of that, the graphics get piped back to your workstation. This is amazing on a network of machines with a common security perimeter. X-Windows was set, as I said, a child of the 80s, so it has a very 1980s security model. And a lot of work has been done to kind of build upon that and try and make it more secure, but it's not really succeeded, right? So one of the things I wanted to get across is that this really lets you put individual windows up. So if you remember from my video, I've grabbed a screenshot here. There's actually two different sort of terminal applications running inside X-Windows. There's a GNOME terminal here running on my desktop, and there's a X-Windows X terminal running in the background. Those are both different windows, so I'm not seeing the whole desktop running on the cluster, I'm just seeing the applications. At UCL, we provide a service called Desktop at UCL Anywhere, which lets you remotely access Windows systems, right? But the difference between that and what we have on the next Windows system is that it basically shares the whole desktop, right? You can see it starting up an entire desktop session here. I can start applications, click around. For some really annoying reason, at the moment it starts up a copy of Teams with every application. But you can launch Word, but you have the whole desktop here. When you're doing it with X Windows, the only thing that's forwarded is the actual application that you're using. Okay, let's log out of that. So this was great in the 80s and 90s when the resources you were accessing were in the same building. They're all on one network. They're all managed by one team. They have the same, as I said, security perimeter. Right? There is no encryption of any kind on X Windows. That's why when we were bringing the applications back, when we're bringing MATLABs as an X client back to our desktop, we used SSH to wrap things in because that way our keystrokes are encrypted between us and the copy of MATLAB running on the HPC system. Our networks are a lot more complicated. The more network hops, due to the speed of light and the amount of time it takes to process moving packets about, the more network hops in between you and the machine that's running the X client, the more lag you'll get. I believe that this is still true, that the X protocol requires not only the write to come to your screen, but then your server to tell the client that the write has happened. And this is a massive lag source. A lot of us are now working on Wi-Fi networks, which are just frankly not as good as Ethernet used to be. Definitely flaky in most buildings. In the corner of the building I'm in now, I don't generally use Wi-Fi. It's actually turned on, but I also have Ethernet in there because quite often it drops out for no reason. You might be trying to work from home and going, well, I've got 100 gigabit broadband or whatever ridiculous invented number your supplier gives you. I'm sure I'll be fine, but there's lots of network hops between you and work. and there might be weird bandwidth restrictions there, or extra latency. So this is not a great tool. Citrix tries to do that a bit better with some encryption and some compression, but it's still an incredibly bad way of accessing applications. So what would be nice would be if we could do like we did on the video where I showed how you run Jupyter on the cluster, if we could run as much as we can on our desktop, right? So if you run a web app, a modern one that's HTML5 and JavaScript, a lot of the interactive stuff is happening in JavaScript in your web browser, and then it's when it needs to talk to something to do something on the server, it then sends messages back. It'd be great if we could do that with MATLAB. That would also allow us to embed it in things like Open on Demand, which is something we're looking at for our clusters, which is a tool which gives you that kind of recipe of web apps that will allow you to access the HPC systems. It turns out MATLAB can secretly do this, and you might expect that because if you've ever used MATLAB Online does exactly this, right? It gives you a MATLAB interface running in the browser. So somewhere in the universe the code exists. It turns out that it is in fact part of MATLAB, and you can access it as a side effect of a thing called the MATLAB kernel for Jupyter. And that's a relatively recent release thing, which was intended to allow you to have a Jupyter notebook that you could put MATLAB code in. But as a rather pleasing side effect, it also lets you run a HTML interface to that copy of MATLAB. And so what we're going to do this is reuse a strategy I used in the previous video where I showed how to do Jupyter, and do that with MATLAB. Okay, so let's go and do that. So first of all, we need to log into Myriad using the port forwarding. So you port forward, and this time I've chosen port 5100 for no particular good reason. Forwarding that port on localhost to that port on localhost on login 12. And then just because it makes my life easier, I'm going to start a screen session. Right, so things we need to do. First of all, we need to construct an environment on Myriad where we have both the Python requirements and the MATLAB requirements loaded. So to set up MATLAB, we need to have, slightly perversely given what I've just said about the X-Windows stuff, Xorg loaded, as well as the MATLAB modules. So if we do module load Xorg utils, that's because it has some libraries that the MATLAB client needs. And then MATLAB, this should pick up the newest version of MATLAB. On that, there's a message here about some setup because we've had some issues in the past with where dot files are stored. So that's good. So if I do which MATLAB, okay, it's R2023A. That's certainly new enough. But we also need to have Python in our environment. And unfortunately, due to some changes in the way the request library works, that means we also need to bring in a newer OpenSSL. And then I'll bring in what I think is the newest install of Python at the moment, which is 3.11. That should work. If we do which Python. Yep. Good. So what we're going to do is, as usual, we're going to create a virtual environment to run this in. So I've created some space for the experimental stuff, just to put it all in one place in my Scratch folder. Okay, put some files in there. There's some MATLAB programs we might use to demonstrate this stuff in a bit. Probably not the GPU one, because I'm not going to ask for a GPU node, because there's a massive queue for those. There's a job script, which is like the Jupyter one before. I'll show you that in a minute. And I've put in this file requirements to text. And what that has is the bits we need to install to make this work. We need to install Jupyter Lab. We need to install a package in Jupyter Lab for Jupyter called MATLAB Proxy. And then this bit's quite important. So Jupyter is in the process of changing how notebooks work. The plugin for Jupyter that manages extensions throws a whole bunch of errors if you use the most up-to-date version of Notebook. So they've moved to this thing called Notebook 7. If you have that, you get a whole bunch of errors on startup. It doesn't actually break what we're trying to do, but those things kind of annoy me. So I've got a requirement here that says we'll install Notebook less than version 7. So what do? We create a virtual environment. Sorry, I was typing this morning. MATLAB. And we'll activate it. Source MATLAB runtime bin activate. And then pip can actually take a text file like that and do that as a one argument install. So do pip install as our requirements.txt. As you can see, I've done this earlier, but some of these things have been updated since then. The nice thing about doing it all as one like this rather than individually is pip will solve all the requirements at the same time. So if you note some of these, it says having to work out versions of things based on the fact that we have an older version of the notebook, but the newer version of Jupyter Lab. Otherwise, you get into this thing where you're installing and uninstalling things. This is works quite neatly. One of the packages PyZMQ has to be recompiled because it's older, so there's no wheel. Right, that's fine. There's a notice there saying we should upgrade pip. I like to do that. Doesn't really add anything. So what we'll do now is we'll do a quick run on the login node to make sure that this all works, and to set up the licensing, I'll show you how you do that. Slightly bizarrely, certainly when I ran it, the MATLAB kernel doesn't pick up the licensing information from the environment. So if we do okay, so it's no longer an environment variable, but if you look in the installation for MATLAB, in fact, there's a folder called licenses, which is where the license information lives. Oops. And there's nothing secret in here. There's a file for our install on the cluster. It's called network.lick. That actually has, it just tells MATLAB where our license server is. So you can't access this if you're not inside UCL's network. So there's no problem showing you this. It just says that we run a license server called licensematlab.ucl.ac.uk, and that it's port 27001. And so we need to retain that information for later, right? Because we will want to put that information into the MATLAB interface. Let's just start a copy of BIM so that we can save that information. Oops, lick mip. Yep. I can't remember if you need the hexadecimal thing, so I'll save that as well, just in case. Right. So we should all be set up now. Let's run Jupyter and see if it works on the login node first. So we do Jupyter lab -- port equals 5100. Let that start up. There we go. Okay, let me open a new browser. And then bring that into existence over here. Okay, so let's open that URL. And you'll see that it starts up the normal Jupyter Lab interface. The difference being two things. One, there's an option here to start a notebook or a console with the MATLAB kernel. But the thing we're actually interested in here is this button, which says Open MATLAB. Let's do that. So this opens the MATLAB interface in your browser. Here it's asking you to prove that you are licensed. So you've got a choice. If you have a MATLAB account, and most institutions will let you register an account tied to your institutional email address. UCL certainly does, right? You can sign into the MATLAB website with your UCL email, create a MATLAB account, and then you can access the UCL license wherever you are in the world, or in MATLAB Online or whatever. But actually, because the cluster is inside the network, we can actually just take that information we put into a editor there. So it is that, and the port is 27001. So I did it earlier, so it's filled in. Click submit. And that's it. It's authenticated that we have a valid MATLAB license. Then it'll try to start MATLAB. The first time this can take a while, particularly on Myriad, because the files, like when MATLAB starts up, it does a lot of stuff on the file system, and that can be quite slow. If we flip over to here, see, so this is nice. This actually shows us something else, which is that when the MATLAB kernel is running, it runs with an open port, so things can connect to it, like the Jupyter server. But it has a single-use token, so that token will be different every time it starts. So once I've closed this, that token will no longer let you connect to my MATLAB server, so that's fine. You can see here, MATLAB is actually putting the MATLAB startup messages in the terminal where we're running Jupyter, so you can actually monitor how well MATLAB is going. So you see it's starting, this is a slow process. Okay, so it says it's timed out even though it's starting. If we just run it again, it should work the second time because it's cached all the disk stuff it was doing before. There we go. So as soon as you see that message in there saying that the HTML interface has started, you know you're in good shape and it's managed to successfully start. You actually see it puts a MATLAB prompt up there. There we go. You see there's a little thing, I don't know if you've used some of our remote desktop things, but there's a little extra widget here which lets you control the session and you can move about on the screen, but it lets you do things. It basically opens that console we've just seen so you can start and stop MATLAB. But here you are in a MATLAB session, right? We can open the canonical calculating pi example and we can quickly run it. And it runs. Okay, so that was the easy bit. That was just doing it on the login nodes. But you'll see this interface is, much snappier than it is running through X-Windows or was if you look back to the old video. Let's exit that. So we can shut that down using this little tool here. So stop MATLAB, confirm. Okay, and then we can shut down the Jupyter notebook. Just close that so we don't get some errors. Right, so that was running on the login nodes, which you should do. If you remember back to the tunneling all over the place video, we showed how you can create a job script which does all the port forwarding for you. So the job starts on a compute node, it tunnels back to the login node, and then the tunnel you've set up to the login node lets you connect to that server running on the compute node, right? And if you need to understand how that works, you should go back to the to that video and watch it. Slightly need to change the locations of things, so let's make sure this is pointing to the installation we've just done in Scratch. So we called it /scratch MATLAB demo MATLAB runtime. Inactivate that. Okay, so if we remember how this works, we set a port, we tell it which login node we're using, we set umask so that when it writes out this log file, only we can read it, because again, that token, both the one this time for the notebook and the one for the MATLAB server, would allow people to run code on our machine if they see them, so we want to make sure they're protected so no one else can see them. We load the virtual env environment. Well, we load all the modules we need, so that's the Xorg utils, the MATLAB, SSL, and Python. We activate the virtual environment. We tell SSH to create that tunnel, with a control socket so that we can shut it down at the end of the job. We run Jupyter Lab. We make sure we forward all the output into a log file that we can look at, and only we can look at. And then when Jupyter Lab exits, we use the SSH control socket to tear down the tunnel. Okay. So let's submit that. And then wait for it to run. Okay, time has passed, and I believe our job has started. We should have the log file in our job script. Yep, there we go. So if we look at that. Okay, we scroll down, we find the URL that we need to connect to with the right token. And then we open it in our browser. Do that. So there we are. We're back in MATLAB. Let's prove this is a login node by opening a terminal. So it says here node D97A015. That means it's one of the D class nodes. Is that? So what we want to do now is open MATLAB, right? It may or may not take a while for this to start, depending on what's cached where. If we flick back to here, we can actually do tail F Jupyter log. It starts up MATLAB. There we go. It starts up the interface. We can see back there. And here we have MATLAB with a web front end, just like you would have on MATLAB Online, running on a compute node in Myriad. We can do all the things interactively we do interactively. We can run the parallel versions of these things. So there's a parallel 4 version of the MATLAB Calc Pi estimator using Power 4. This will exhibit all the behavior of running it locally. So the first time we run the parallel 4, it will set up a thing running through, setting up workers. Those workers will take a while to start up, but subsequent runs will be fast. So if we do calc pi Power 4, and we then wait for it to start up, should see here this little parallel workers parallel pool thing should show up in a second when it starts up the pool. There we go. And again, like I said, because it's a web interface, this is snappy, right? There's not any, there's not sort of that drawing lag that we had with the stuff in X-Windows. Go. It's now actually doing the work. Go. So the first time, because it took, well over a minute to start the pool, it took 78 seconds, but if we run it again, fractions of a second, right? What else can I show you? You might wonder about security. So it says this URL here. Well, is this open to the world, right? Well, first of all, it's in a local loopback interface, but say you're on a multi-user machine. Can someone connect to that? No, they get the Jupyter authentication stuff, so they need to get the things that they've been authenticated. So if you've got like a, it's the usual Ingress stuff. On the network side, if someone else is logged in to the compute node for some reason, and they do a PS, the token for MATLAB is not anywhere on the command line, so they can't get in that way. So it's not perfect. Like, it could use domain sockets, for example, for a more secure way of talking to the kernel. But because this also runs in the same way if you're doing this on Windows, Windows doesn't have domain sockets; it has its own internal socket thing. This is pretty much the best way for them to have done it, and it all works. So I guess